Hello there. In this brief video we're going to be looking at tree diagrams and probability. Now let's start this by looking at a particular question. Bernie has an ordinary pack of 52 cards. These are shuffled and a card is drawn at random. The card is recorded and then replaced. This whole bit about replacement means it's going to be a grade B question. In another video I might well be able to look at where you don't have replacement. A second card is then drawn, the suits are recorded. What is the probability that both are hearts? It's our first question we're going to try and answer. One is a heart and at least one is a heart, which is not the same question as B. Now, to make life easier, I'll just go through the suits in a deck of cards. We have hearts, we have diamonds, we have clubs, and we have spades. So there's 4 possible suits could be drawn each card, but if we look at the question, it's all about hearts. So I'm going to simplify things, as you'll see in a moment. So let's have a look how we construct our tree diagram. So our first card drawn. The first card drawn could be, because I'm only interested in hearts, could be one of 2 things. It could be a heart, or it could be not a heart. Now, the second card, again, will follow the same pattern. It could be a heart or not a heart. So look at all the possible outcomes. I could have drawn a heart with my first card and a heart with the second, or I could have drawn a heart with my first card and a not heart with the second. What other possible outcomes could there be? Well, I could have drawn not a heart, one of the other suits, and then drawn a heart, or I could have drawn not a heart and then not a heart again. Whoops, Daisy. Colours went a bit wrong there. Now, that's the first part of drawing my tree diagram. Next, I've got to work out the probabilities. Now, before we go any further, just remind you that there are 4 different suits in a deck of cards. You probably won't get one as complex as this because not everybody plays cards, and therefore the examples, and they try to be as fair as possible, don't want to penalise anybody. For instance, those that come from a background where playing cards are frowned upon. There's 4 different suits, and they're all equally likely. So what's the probability, audience, that I would draw a heart? Audience member?
A quarter.
1 out of 4, yeah. There's 1 suit of hearts out of 4 suits. So what's the probability, audience members, that I draw not a heart?
3/4.
3/4, yeah. These 2 probabilities must add up to 1. And because I replaced the card, these probabilities don't change. So if you have replacement, okay, and the probabilities don't change, then I can just write these all the way across every branch of my tree diagram. Now, let's use the tree diagram to answer the questions. The probability that both are hearts. Well, that's this succession of branches. First card is a heart and the second card is a heart. So the probability that I draw 2 hearts, you can use a calculator here, is going to be a quarter. Now, does anybody remember? It's a quarter for that one and a quarter for that. Do I add them? Do I subtract them? Do I multiply them? What do you think, audience members?
Times them.
You times them, yes. And the good news is you don't have to simplify when it comes to probability. So remember how you multiply if you haven't got a calculator here? Multiply the numerators and the denominators and we get the probability of getting a heart followed by a heart is 1 out of 16. So that's question A answered. Now what about question B? It said 1 heart. 1 is a heart. Now let's just get rid of this highlighting here. The probability that 1 is a heart. Well, let's go through this. We have to think a bit about this. I could draw the first card a heart and the second card not a heart. However, there is another route by which I could draw 1 and only 1 heart. Can anybody spot what it is? Audience member?
3/4 to 1/4.
Yeah, my first card could not be a heart, and then the second card could be a heart. So we've got two probabilities to work out. So the green succession of branches was 1/4 times 3/4, which is 3/16. And the yellow succession of branches, that means, you know, that was not getting a heart and then getting a heart, was 3/4 times 1/4, which again is 3/16. Now what do I do next? So the question said, what's the probability of getting 1 heart and 1 heart only? Do I choose one of those? Do I multiply them together? Do I add them? Do I subtract them? Audience member, what do I do when there's two possibilities, two possible ways of getting 1 heart?
You add them.
Good. Because we're now looking at this word here, or. I could get a heart and not a heart, or I could get not a heart and a heart. And when you hear the word or in probability, you add. So the probability that I get 1 heart is 3/16 added to 3/16, which gives 6/16. Now the final question said, and we just want to emphasize this word at least, because it catches many students out. Just pause. Now the last question, welcome back there. The last question said, what's the probability of getting at least 1 heart? Now you have to be on the ball. It's all about really comprehension. At least 1 heart means you get 1 heart, of which the probability was 6/16, or of course you could get both of them, 2 hearts. So either of those, this or that, could satisfy this condition, the probability of at least 1 heart. Now remember again, 6/16, or sorry, what do I do here with the 6/16 and 1/16? You add them, yeah, because the word or appeared there. And there we go. The probability of at least 1 heart is 7/16. Just finish off. There was an alternative way of doing that. I could have worked out the probability of getting no hearts. Now the probability of getting no hearts if we look at our tree diagram, probability of getting no hearts is 3/4 times, I'll do it in a different colour, it's 3/4 times 3/4. So probability of no hearts is 3/4 times 3/4, or 9/16. And then I could have subtracted that 9/16 from 1. The probability of not getting no hearts, sounds bad English, the probability of not getting no hearts is the same as the probability of getting 1 or more hearts. So I could have done subtraction there. Okay, thank you for listening. Right, now tree diagrams. What is the problem?
Okay.
Yeah, I noticed that.